arguing that the microscopic world is uncertain. The negative side, led by Einstein, represented the classical physicists, asserting that the microscopic world is certain. First, let's welcome the affirmative side, the Copenhagen interpretation. They are: affirmative first speaker, Heisenberg; affirmative second speaker, Pauli; affirmative third speaker, Dirac; affirmative fourth speaker, Bohr. Next, let's welcome the representatives of the classical physics side. They are: negative first speaker, de Broglie; negative second speaker, Schrödinger; negative third speaker, Lorentz; negative fourth speaker, Einstein. I am Fourier, the moderator of this debate. It needs to be specifically stated that Lorentz, the third opposition speaker, was just an observer. But because of his quarrelsome and undisciplined behavior, he always taps the table when he's excited. I can't criticize him because he's so respected, so I've assigned him to Einstein as the third defense. Now, let's invite Heisenberg to the stage. He's the one who started this debate. It's his uncertainty principle that started this debate.
Why is the microcosm uncertain? Let me give you an example. To measure the position of an electron, you have to look at it with gamma rays, which have a shorter wavelength. But the electron is very small. The gamma ray hits it and it goes everywhere. Momentum can't be determined. If you want to measure the momentum of an electron, you need a longer wavelength photon to shine on it, to avoid the photons disturbing the electrons. But then you can't determine the position. So there's no definite value for the electron's position or momentum. So the behavior of microscopic particles is unpredictable. It's as simple as that.
Heisenberg, the example you just gave only shows that the existence of the uncertainty principle is due to current observational constraints and theoretical limitations. It doesn't necessarily prove the uncertainty of the microscopic world. There may be unknown hidden variables in physics that could determine the states of microscopic particles without relying on probabilistic wave function descriptions.
I'm giddy from the opening credits. Should I criticize you two for being pretentious, or despise myself for being uneducated? Next, Schrödinger, the second defense, please come to the stage. I hope you've given me an example I can understand. Otherwise, don't blame me for being biased in favor of the positive side.
The moderator said this. I'm under a lot of pressure. I'll try to use examples from the macrocosm to show that the micro world is deterministic. Suppose there's a closed box. There's a living cat in the box, radioactive material, a gas bottle, a switch, a hammer. If the radioactive material decays, the switch activates the hammer to break the gas bottle. The cat is poisoned. According to the Copenhagen interpretation, the radioactive material is in a superposition of decay and non-decay, so the switch is in a superposition of on and off. The gas bottle is also in a superposition of broken and unbroken. The cat is in a superposition of life and death. As long as you don't open the box, the cat could be both dead and alive. Oh my God. There's a cat that's alive and dead.
This must be the legendary Schrödinger's cat thought experiment. It's a privilege to hear it live. I'm so lucky.
Radioactive substances, this I'm familiar with. Feel like this example of Schrödinger's is kind of awesome.
I'm a melon eater. If I were to replace this cat with me, I'd be an intersex person.
Ha ha ha, I'm also a fan. I have to admire Schrödinger's brain hole is really big.
Heisenberg, it's your turn to respond. Of course it is. Don't argue hard.
Schrödinger, you. This cat of yours is just a fictionalized example of a macroscopic scale, and not a typical situation describing the behavior of microscopic particles. It's usually at the microscopic scale the uncertainty principle comes into play. This cat of yours. It's over 20 pounds, right?
I'm following your theory. I'm using this cat to connect the macrocosm to the microcosm. I'm using the cat to disprove the absurdity of your microscopic quantum theory. What's the problem?
I've never seen you have a cat, huh? So tell me, do you have a black or white cat? Is it a Chinese civet or a Persian blue-eyed?
Heisenberg, you're getting a little off topic here. Looks like the cat's a bit of a tough nut to crack. I now give the floor to Defense 2.
May I ask the opposing side, Defense 1, if it's not necessary to rely on a probabilistic description of the wave function, Then what exactly is it relying on?
Polly, do you understand what I mean by matter waves? A particle is a singularity in the wave equation. It's like a packet on a wave. It must be guided by the wave. And this wave is actually the trajectory of matter, which we can explain by the law of cause and effect instead of a probabilistic explanation.
If the wave is the trajectory of matter, then tell me instead, what's going on with this motion? Forward, backward, toward heaven, or to hell?
Pauline, you are worthy of the legendary barbarian. No. You are the god's whip of science. You've got the other side's first defense speechless. No wonder Yang Zhenning is sweating. Now it's time for the free debate. Please take your seats.
De Broglie mentioned matter waves and the law of cause and effect. But even if we accept that, it doesn't mean that the behavior of microscopic particles is certain. The Dirac equation, which bears my name, predicts the spin of the electron and the existence of the positron. And these predictions have been experimentally verified. In conclusion, uncertainty is not a flaw. It's a fundamental characteristic of the world. We should accept and understand it instead of trying to deny it.
Finally, it's my turn to play. Quantum mechanics is not part of my specialty, but when it comes to electrons, I still have something to say. On the macroscopic scale, Dirac, your equations predict the existence of electrons and positrons, but it can't determine the position and velocity of the electron at the same time. So, the uncertainty principle is not a fundamental property of the world. It's a flaw in quantum mechanics. You kids in Copenhagen, I think it's just not working.
Please ask the moderator to control the scene. Lorenz is much less likely to scare the timid Dirac. Let's not engage in verbal sparring. Or return to theory. The positions and velocities of the particles. They interfere with each other when they're measured. This is the core of the uncertainty principle. But uncertainty is not a barrier to understanding the microscopic world. It's a tool for understanding the quantum world. Of course, waves and particles are mutually exclusive at the same moment, but they're unified at a higher level. Perhaps in higher dimensions.